Hey listeners, are you ready to uncover some extraordinary wonders? Disappearing Spoon is thrilled to partner with the amazing Curiosity Box. It's a science subscription service for curious minds. It's created by Vsauce, the internet's leading science education channel, with over 3 billion views. This season's box is packed with goodies that will fascinate and inspire you. Challenge yourself with a magnetic shadow alphabet puzzle. Piece it together to spell out the alphabet using only the letter shadows. Or discover the picture pot, where art and mathematics merge into a colorful, creative masterpiece. It is fun and educational. And the highlight, a sample of recreated Martian soil. Experience the thrill of holding the red planet right in your hands. Don't miss out on this unique adventure. Subscribe to Curiosity Box now and celebrate the incredible achievements of science. For 50% off, use the offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon. That's offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon for 50% off today. Unbox the mysteries of the universe with Curiosity Box. Farm life is always hard, but young Edward Knipling had it worse than most farm kids. Knipling grew up in southern Texas in the 1910s, and his family was too poor to afford veterinary care. So the worst job on the farm fell to him, picking screwworms out of open wounds on cows. Now, the name screwworm is a slight misnomer. As adults, they're actually flies. They look like houseflies, with metallic green bodies and orange heads. But before turning into adult flies, screwworms do have a worm/maggot phase, and it is utterly disgusting. These maggots can infiltrate any wound on any animal, even tiny mosquito bites. And once inside, they'll start devouring its flesh, turning tiny wounds into huge, dripping ulcers. So imagine little Edward Knipling picking maggots out of these wounds by hand before they killed the family cows. Understandably, this produced a lifelong hatred of screwworms in him. Now, Knipling did not hate all bugs. Far from it. He eventually became an entomologist, and he even named his pet Siamese cats after insects. One cat he named Autonomous, after a weevil. One cat was named Culex, after a mosquito. But screwworms? Screwworms. Knipling hated those vile little things. So when he landed a job at a small, run-down U.S. Department of Agriculture lab in Texas, he decided to study screwworms in detail, looking for any weakness that could destroy them. It did take a while, but in 1937, he finally found this insect's kryptonite. Or at least he thought so. It turns out that screwworm flies have an unusual mating system. Male flies mate promiscuously, with up to a dozen females if they can. But female flies are picky. Females have sex once, and then never again, even if they do not get pregnant. Now, to most people, this would probably seem like a useless fact. Who cares about screwworm sex? But that's what separates Edward Knipling from most people. His intuition told him that this fact was vital, somehow. He started racking his brains, turning the idea this way and that. How could it help him eradicate screwworms? The plan he eventually came up with was later called, by no less than the New York Times, quote, the single most original idea of the 20th century. Now, that might seem like hyperbole. After all, we did get computers and airplanes last century, too. But after learning more about it, I don't think it's crazy hyperbole. I think you can make a case that what Edward Knipling envisioned just might be one of the more revolutionary ideas of the past 100 years. From the Science History Institute, this is Sam Keene and the Disappearing Spoon, a topsy-turvy, science-y history podcast where footnotes become the real story. I'd like to thank listener Barbara Hafner for suggesting today's topic. Although, I guess I should blame her as well for all the heebie-jeebies I suffered when reading about screwworms. Now, I say that jokingly, of course, but I'm not exaggerating when I say how disgusting screwworms are. Screwworm flies lay eggs on any open wound. And again, they turn even tiny mosquito bites into gaping, pulsating sores filled with thousands of wriggling maggots. And if that isn't bad enough, screwworms also lay eggs on mucous membranes. Eyes, lips, the anus, the vagina, they devour them all. Monkeys in Panama sometimes tumbled out of trees after screwworms ate their eyeballs out. Screwworms also burrow into the belly buttons of newborn baby deer and eat their flesh from the inside out. And if that still is not disgusting enough, well, screwworms also infect human beings. I will spare you the worst details of where. But seriously, I have seen some vile pictures. They are one of the worst parasites on Earth. So you can imagine why Edward Knipling was determined to eradicate them. Knipling was a tight-mouthed man with thin brown hair and dark, intense eyes. Eyes that bored right into you, kind of like screwworms did. And in 1937, the solution to eradicating screwworms suddenly came to him. The big leap that carved his name into science history. Again, the key fact was this. Male flies mate multiple times, while female flies just once. So Knipling came up with a plan. What if he could mass-produce sterile male flies in the lab, then release them into the wild? Now, this might sound a little backwards. He's going to eradicate screwworms by releasing more screwworms? But remember, adult flies don't feast on animals. Only young maggots do. And after a few weeks, those sterile flies he released would die of old age, since flies have short lifespans. And here's the benefit. If you release sterile male flies, some of them will mate with fertile females, perhaps several fertile females. And because females mate just once, those females will never have viable eggs now. You've effectively sterilized them, too. They will never reproduce, and overall population numbers will therefore drop. Now, of course, there would still be fertile wild males out there to mate with other females, so this would not eliminate screwworms in one swoop. But Knipling reasoned that if he kept releasing swarms of sterile males over and over and over, he could drop the population numbers more and more each round. Eventually, it would reach zero. It was a war of attrition, and pleasingly, one that used no noxious chemicals or insecticides like DDT. In fact, after he released them, the flies would do all the work. He was essentially harnessing the natural drive to screw to make the screwworms screw themselves. Unfortunately, right after his epiphany, Knipling got diverted into other work. This was during the Great Depression. People were already starving, and there were outbreaks of agricultural pests in Illinois and Iowa. Then World War II erupted, and Knipling got roped into fighting disease-carrying lice and mosquitoes abroad. Meanwhile, in addition to those other distractions, he also needed to find a way to sterilize the screwworm flies. He tried method after method, but every single one of them failed. The answer finally came to him in 1950. Knipling was reading a magazine story, which mentioned that exposure to X-rays can cause sterility in animals. So he thought perhaps X-rays could sterilize screwworms. It seemed worth a shot. The only problem was Knipling still worked at that lowly U.S. Department of Agriculture lab. They didn't have an X-ray machine, and they didn't have the money to buy one either. He couldn't just request funds from Congress either. Oh no. In fact, Knipling lived in terror of Congress ever finding out about his work. You see, as a USDA researcher, Knipling was spending taxpayer dollars. And just like nowadays, know-nothing members of Congress absolutely loved to pounce on pointy-headed scientists who they assumed were wasting government cash. Knipling's work seemed especially ripe for ridicule. What kind of pervert studies screwworm sex? It was practically un-American. So beyond his lab, Knipling kept mum about his research. No funding requests. Thankfully, he found out that a colleague named Raymond Bushland knew some X-ray technicians at a hospital on a military base near San Antonio. So Bushland suggested sneaking some flies into the hospital to experiment on them when no one was around. Now, this was kind of a nutty idea. Military bases are not exactly wild about people sneaking onto them, especially into hospitals with wounded veterans, and double especially while carrying parasites that feast on open wounds. But Knipling was determined. He agreed to the smuggling operation. Sadly, the details of this caper have been lost to history. But I imagine Knipling duct-taping boxes of screwworms to his body under his shirt, then maybe sneaking into the hospital's loading dock and darting from doorway to doorway down empty corridors. Very Mission Impossible. Regardless, Knipling got the screwworms inside. And over a few weeks, he and his team zapped them at various stages of their life cycle. The results were pretty encouraging. If they zapped the flies during their teenage or pupal phase, the flies would grow into adults who were anatomically capable of mating, but lacked functioning gonads to release sperm and eggs. Perfect sterility. At this point, Knipling was beyond excited. His dream of eradicating screwworms was within his grasp. He just needed to confirm things with a real-world test. He finally got the chance in 1951, and the test turned out to be a complete flop. In 1951, Knipling ran his first real-world experiment with sterile flies on Sanibel Island off Florida. Deer there kept getting infected, and the island was small and obscure, perfect for a clandestine test. To deploy the flies, scientists dropped them from airplanes in cardboard boxes. The boxes were refrigerated beforehand to keep the flies sluggish. But as soon as they hit that warm Florida air, they sprang awake and zipped off to mate with fertile females, and hopefully to crash the screwworm population. But the experiment simply did not work. The population sank a little, but it never dropped to zero, despite months of labor. As for why things failed, Knipling did not know. Maybe they hadn't bombarded the island with enough sterile flies. Or maybe fertile screwworms were flying over from the mainland a few miles away. Or maybe the idea just wouldn't work. The only thing Knipling did know was that he'd failed, and that he was happy that he'd kept his mouth shut. He didn't need Congress knowing that the screwworm sex guy couldn't even run a proper experiment. Thankfully, Knipling did get a second chance. In 1954, an outbreak of screwworms began ravaging the island of Curacao off Venezuela. Goats there were dropping like, flies, and the rural population faced starvation. So a desperate official there wrote to Knipling. He didn't know about the sterility experiments. He just knew that Knipling was a screwworm expert, and he begged for help. Now, Knipling had no idea where Curacao was. He had to pull down an atlas to look it up. It lay 20 miles north of Venezuela, which was good. Flies could not zip over from the mainland and reinfect the place. Equally good, it was far from the United States and its penny-pinching Congress critters, totally under the radar. Knipling and his team soon began drawing up plans. This time, they wanted to make sure they released enough flies. So they basically set up an industrial factory for mass-producing flies, which was every bit as disgusting as it sounds. The fly factory opened in March 1954. Inside, there were whole troughs of writhing maggots just lying around. And they fed the maggots with a slurry that Raymond Bushland had invented. Raw hamburgers soaked in blood and formaldehyde, 40 tons every week. Imagine the stench. But the flies thrived. and the factory churned out 170,000 sterile flies every week, then released them into the wild. This time, the results were stunning. The screwworm population collapsed, and within 9 months, Curaçao was screwworm-free. Best of all, the project cost just $20,000 and used 0 insecticides. Pretty soon, Knipling felt confident enough to go public with his ideas, and he had good timing in doing so. Screwworms were overrunning several southern states by then, devastating whole herds of cattle, plus wildlife. Ranchers were desperate for help, so much so that even the know-nothings in Congress swallowed hard and gave the screwworm sex guy some cash for more research. Given how vast the U.S. was compared to Curaçao, Knipling's team had to build an even bigger facility for mass-producing sterile flies, a whopping 200 million of them every week. Imagine all the rotting hamburger. Then they would load the sterile flies onto airplanes for deployment. Reportedly, the boxes of flies smelled so bad that some pilots refused to take them as cargo. The scientists took to buying cologne in bulk to spray the boxes down. But once the odor problem was solved, the eradication campaign soared. By just 1966, screwworms had been completely eliminated in the United States. And scientists weren't done there. In the 1970s and 1980s, they devised a wildly ambitious plan to push the screwworm all the way down to Panama and eliminate it from North America entirely. This plan took place against the backdrop of some serious turmoil in Central America, guerrilla battles and coups and insurrections. I've actually put together a little bonus episode about this at patreon.com/disappearingspoon. Check it out. It's a fascinating story. But suffice it to say that the United States remains screwworm-free today. And given that success, you might be wondering, why haven't scientists used this sterile insect method against other insects? And the answer is, they have. It's helped fight agricultural pests like melon flies and onion flies and bollworms. Most importantly, it's helped combat the tsetse fly, a blood-sucking critter that transmits diseases in Africa. Then there's mosquitoes, the deadliest animal on Earth, responsible for spreading malaria and yellow fever and all sorts of other terrible things. Just like screwworm flies, most female mosquitoes mate just once, so mosquitoes seemed perfect for the Knipling sterility treatment. Unfortunately, there is a problem here. I mentioned before that Knipling's original idea was to sterilize and release male flies. Releasing sterile females doesn't help, since they don't mate with other females. In fact, releasing sterile females works against you to some degree, since sterile males might waste time and energy mating with them, and thereby miss opportunities with fertile females. But that brings up a huge problem: separating the boys from the girls. How on earth do you determine the sex of itty-bitty eggs? Knipling and his colleagues had ideas. Males and females have different body structures, and therefore different densities. So maybe they could float male eggs in water, or centrifuge eggs to separate the sexes. But those ideas turned out to be impractical. It's just too much work to separate male screwworms from females. So most programs sterilize them all and release both. It's not optimally efficient, but the sterile females don't do much harm, so it's not a huge deal. Unfortunately, mosquitoes would not be so forgiving. In mosquitoes, only the females bite animals for blood and spread diseases. So if you ran the Knipling sterilization process and released sterile female mosquitoes, you might actually increase the spread of disease. Bad idea. So the Knipling process has been a non-starter with mosquitoes. But there is hope. I mentioned tsetse flies a moment ago. In that species, scientists have found ways to quickly sort males from females by shining light through the eggs. In theory, you could then zap the females with lasers or whatever. So maybe some smart young listener of this podcast will figure out a way to do something similar with mosquitoes, making the Knipling treatment viable. Or if you want to get a little sci-fi, we might even take Knipling's general idea in a whole new direction using CRISPR and so-called gene drives. There are more details about this in the bonus episode at Patreon. But the larger point is this. Knipling's basic idea was to create a variant of a species in the lab, release it, then turn the mating instinct of animals against themselves. And if we can somehow do that to fight mosquitoes, either by quickly separating males from females or by harnessing CRISPR and gene drives, then we might be able to wipe out malaria and other diseases the same way we wiped out disgusting screwworms. And in my book, freeing human beings from the misery of those ancient diseases would be right up there with computers and airplanes. 100 years from now, the Knipling technique really might seem like the best idea of the 20th century. This is the Disappearing Spoon podcast, brought to you by the Science History Institute. Find out more about their library, museum, and multimedia magazine at sciencehistory.org. Make sure you check out the Science History Institute's other awesome podcast, Distillations. You can find their in-depth narrative stories and interviews about everything from space junk to sex, drugs, and migraines, anywhere you get your podcast, and on their website, distillations.org. You can find more incredible stories from my books at samkeen.com. You can also book me as a speaker at your school or event. If you like this podcast, please support it at patreon.com/disappearingspoon. It costs as little as 7 cents per day. You can also get bonus episodes and signed books. Please spread the word to others as well, and subscribe in iTunes, Stitcher, or other places. This episode was written by me, Sam Keen. It was mixed by Jonathan Pfeffer and produced by Mariel Carr, Rigoberto Hernandez, and Padmini Raghunath.